Zijn vragen ingesteld vandaag?
Zou je als je op 8 mei al als je sneller bent
Ja, aan de ene kant denk ik dat is wel. Als je 8 mei doet, dan heb je nog maar. Nee, 2 toch?
Ik denk niet dat daar.
Ik heb heel vaak bij jij, dus kan ik dan vragen.
Mijn kabel. Ja, wacht, ik zet hem even vast. Oké. Oké, zo we hebben beeld. Kom ik verder niet meer aan.
Ik ga gewoon kijken naar je
It seems like all systems are up and running. I'm sorry for the inconvenience about the delay with all the projection thing. Probably the error was on my side somewhere with this connection thing. It's a bit fragile now, but it's sort of working. I'm gonna stop the recording and start it again because we don't want to have all this mishap in the recording. And the streaming was up and running. If there's any problem of streaming, I think somebody will call you and then I will hear. I see the sound is okay. Okay. Sorry for this mishap. Where is my screen? Where's my air server? Air server. Okay. I will not connect it. Fix that. That is set. Yeah. Okay, and then we go to today. Okay, it's good. Huh? Help. What is this? Yeah, okay. To be frank, this is always my nightmare. That some of these things is not working. I mean, it's a very fragile system. If one little kink in the system is broken, then the whole system isn't working. So my nightmare came true today. Okay, today's topic, closed loop systems and coordinate projection method. How was the homework last week? Tough, eh? Yeah. Me too. I had a hard time making the solutions. Yeah. Well, actually a lot of work. So, oh, now this dropped out. We can get that back. That's no problem. It probably has to do with the wireless connection. Looks good. Anyway, we're going to start with code, right? That should work. Sound is here muted, yeah. Code, where are thou? Yeah, here. Codes. Number 7. Play. Classic. Yo. Let's give it a little bit more time for those who thought thing is not going to work today, and then suddenly see, oh yeah, it is. Well, this is usually the number which is in the quiz, right? 118 or 120. Okay, ready, set, go.
En dat moet lineair, dat moet zo. Ja. Ja, dat is van 16 uur, dus hij is meer zo. Dus hij doet stijgen. Dus je wil niet, dus niet 1 of 1. Probeer het zo dat het nee, het duurt wel snel. Het is een beetje.
Yeah, it was easy, right?
It's not working.
So, in the room?
Oh, huh? Oh. The thing is not working. No.
Still and loading.
Do it so.
Yeah, I see it. From het... Heb je wel internetverbinding? Want misschien...
Ja, ja, ja.
Dat is wel een beetje terug.
Ik ga gewoon een nieuwe vraag.
A is toch 4? Dat is B. Ja, oké. Want A is er ook 4. Ja.
Doen jullie het weer? Doet hij het weer bij jullie?
Ja, ik weet niet of je niet. We hebben geen punten. We net wel het antwoord hebben.
Phone.
Ja, maar is er net een antwoord gekomen? Ja. Welke was het? Welke categorie?
Nee, maar wij hebben geen punten.
Oh my god, no one's been there. Maar wat zeg je? Hoe is het dan voor mij als het
Ja, maar net.
Ja, oké, super easy, right?
Hij geeft geen punten of het goed is of fout is.
Ik weet niet wat ik daar aan moet doen.
Oh, dat weet ik. Dat is... ja, het is veel. It's all about...
Werkt het voor jou?
All about
Doet hij het, ja? Ja. Maar je kan wel stemmen. Oké, nou dan... Ja, volgens mij loopt het wel, maar ja, het is een technology day like this. Ik weet niet wat het is.
Ja, maar
Ja, okidoki. Yeah, the green one was also an option. So the red one and what is this, blue? No go, because you're adding up three things and then it should be h over 3 at least. And likewise here it should be h over 4. But these are okay. And they could both be right. There is a scheme which uses this, but then the K1, K2 are different points in time. Okay. This is a more tricky one. Read closely what I'm asking, eh?
Ja, maar welke?
Oh,
Ja, trouwens, het is niet koos.
Op de WhatsApp zeggen ze nu dat Kahoot gecrashed is bij een hoop mensen.
ja, hier ook in de zaal.
Ja.
Ja, dankjewel voor de mededeling, maar zolang ik mensen heb waar het nog bij werkt, vind ik het een beetje lullig om het te stoppen.
Ja, maar waarom is dat niet rood?
ja, dat is twijfel.
Rood wel? Ja, want rood, maar rood, blauw neemt alleen maar het A in. Nee. Ik weet niet of het zijn for solution along the round. Er is maar één masker voor blauw.
Je moet
Het ding is, er staat daarna
Oh, rood alleen maar.
Ik heb de hele week ben ik nog steeds zo goed hard. Ik denk wel dat dat fout is.
Okay, this asks for some feedback, right? So let's try and give some feedback. So only 22 are correct. The correct answer is apparently green, so something with a cosine, and then the difference in the angular speed between alpha and beta, or A and B. Okay, let's look at the problem. So we are seeking the velocity by when this point hits the ground in the 4½ direction, right? That is the question. Meaning that we have to find the velocity of this point and then project it in this direction, correct? So how do we find the velocity of this point? Well, we start here because that's zero velocity. Then we calculate the velocity of this point. Then we add the relative velocity of this point with respect to this one. And then we have the total velocity. And then we project it on the horizontal. What is the velocity of this point? Well, it's L times A dot. And it's perpendicular to this leg. So it's somewhere in this direction. So the projection is cosine alpha of that, right? Then what is the velocity of this point with respect to this one? If this is minus beta, then in this direction, it's beta dot times L. right? We have to add that up, and we have to take the projection. So in conclusion, L cosine alpha times alpha dot minus beta dot. Brush up your kinematics. Okay. Last question, and that's for on today's topic. You have 120 minutes, so take your time, do the calculation. Minutes, seconds.
Oh, the shortest distance to us.
Ja,
Dat is allemaal wat nu 1 keer min 1 is 1. Nee. Als ik
Goed, toch?
waarom doe je dat?
Maar hoeveel is het zo?
Nee, ik geel op die 2 antwoord. Maar rood ook, rood is een rood, maar wat valt dan? Wat is the shortest distance to the origin?
Je hebt nog mensen naar de juiste. Oh, je wilt het gewoon even kijken wat het
Yeah, very good. So what is the problem here? The red one and the blue one, they are solutions, right? But I asked for the shortest one, and of course there's an infinite number of solutions for this undetermined system. And then, well, actually this one didn't suffice. This was not a solution. So these three, the green, the red, and the blue are solutions. And then what is the shortest distance? Well, then you have to take the norm. Well, the norm for this one is 1. This one is square root 2. It's bigger, so forget it. And this one is square root of 6/9. So that's less than 1. Yeah, so this is the shortest from all these answers, and it's really the shortest. Okay. Yeah, get the results. Save the results. So works.
Ja.
Yeah, I guess feedback is low because things are not working. We will see what happened. Okay, then we stop with this. We stop with this. Live stream is still up. Then we go to. This can go away. We go to this guy. Yeah. Enlarge it. Okay, so closed loop system and coordinate projections. Now, until now we have done sort of 2 methods to get the equation of motion. There was the DAE approach and the independent generalized coordinates. Now, let's focus on the independent generalized coordinates because that's sort of a beautiful system where you reduce the equation to the necessary ones. You don't have to drag along all kind of constraints. But finding this whole transformation, so finding xi expressed in terms of your generalized coordinates qj, is not so easy. Well, it is easy when you have an open loop system. And it's not so easy for closed loop systems. And what is a closed loop system? Well, the most simple closed loop system is a 4-bar mechanism, right? So let's draw this. 1 bar, a 2nd bar, and then there's a 3rd bar, and then they're both connected to the ground. We have center of mass here. Body 1, body 2, body 3. Now, how many degrees of freedom has this system? Three, 2, 4. What is, so you have, I believe, that's a religion, and we have science. So let's do some science. I mean, according to a religion, we get all kind of numbers. And maybe even the numbers will start fighting, like in religions. But science, there's usually only one answer. Well, not if you have an undetermined system, but... Okay, so science. How many degrees of freedom? We have 3 bodies, and every body has 3 degrees of freedom, so that's in total 9. And we have 1, 2, 3, 4 joints with 2 constraints. Minus 4 times 2 equals 1. And that complies with my religion, my belief. Because if I look at the system, I think, oh yeah, you move that crank, and then this moves, and that moves, and then it's probably 1 degree. And then usually we like to take like this as an input angle, and then we're interested in the output angle here, or we want to know what the curve is that one of these points does in space. Okay, let's put some dimensions to the system. So this has a distance d. The beams are A, B, and this is a length C. So geometrically now everything is defined. And we like to know now, can we write down this xi is ti of qj? And let's be specific, what are our xi's? It's x1, y1, phi1. Oh, Heike is yelling at me. Remember? X, y, phi. So, coordinate system. x1, y1, and of course body 2, body 3, and then we're in business, right? That's it. So in total 9. And then for our generalized coordinates, well, it's 1 degree of freedom. Pick your number. I would say let's take the angle of this bar, alpha. So now we have to write these coordinates in terms of this one. Well, that's not so hard. I mean, let's start. x1 is a over 2 cosine, and it has to be in terms of the degrees of freedom. So that's alpha. y1 is a over 2 sine alpha, and phi 1 is, well, that's alpha itself, right? Okay, x2 equals, well, how do we get here? We first go to this point, and then we take that one, right? So that's a times cosine alpha plus b over 2 times the cosine of this angle, but then expressed in terms of this alpha. Do we know what the angle of this bar is expressed in terms of a alpha? That's geometry, right? Okay. So how does geometry go? We draw a skeleton lines. So we want to know this angle beta in terms of this angle alpha, right? And then we write distances here, D, A, B, and C. And maybe we also in the end want to know this minus gamma, this angle. But okay, for now, let's focus on this beta. So can anybody solve for me this problem where I want to express beta as a function of alpha, is. Okay, you have to create some triangles, right? So maybe it helps if we start with this line. Then we have created two triangles. This is a triangle with alpha, and this is the triangle with beta plus some other angle, which follows again from the alpha triangle. Can anybody help me? How does this go? Help. Yeah.
Isn't there a problem because of the V and C can also both?
Yeah, it's not unique, but I choose to take this position. You could also say, oh yeah, this is also a configuration. So it's not a one-to-one mapping. I agree, but in writing down, I will make a choice, and I make a choice of this one. But can we solve it? I mean, can we write down the expression? That is more the bottom line. Well, I always say, well, when you can draw it, you can probably also calculate it. If you can do it with a ruler and a compass, a ruler, compass, and you probably also can calculate it. But it's hard. I mean, you need to be good in geometry and in sine and cosine, and it should be your weekly hobby. And it isn't. I have other hobbies. So I'm not good at this. So then we're going to look at, maybe somebody already solved it for us. And indeed, Mr. Talbourdet, had analysis of a single 4-bar linkage. And he does, well, approximately what I do, only, he calls this A, but now this is phi, and in my case it's alpha, and this is C, and I call it B, and this is D, and I call it C. And B I call D. But forget about it. So forget my notation, look at this. So he says, well, he doesn't do this, he wants the output angle. Also okay, if you know this and this, you probably can also calculate this angle. Anyway, how does it go? Well, you have the theta as input, and you want to know the phi as output, and the velocities, and of course the speeds. But the moment you have this, you can calculate that, hopefully. Then he comes up with some intermediate values. A squared, B squared, minus C squared plus C. I have no clue. A sine theta, so that's probably this distance, right? So he solves his whole geometry problem, and he solves it, of course, by also drawing this line and drawing this line and calculating the projections and so on. And probably also a line here. Anyway, the solution is something like this. Phi is arctangent of these constants, which are in itself also a function again of theta. So a mess, right? If you express everything in theta, it's a mess. And then if you want to differentiate it with respect to time, the mess becomes larger. And if you want to know, the acceleration becomes even larger. So yes, for this very simple basic case, there is some sort of solution, which happily somebody said it's not unique. So we're even not happy with that, but we have a solution, but it's not very useful, I would say. At least I cannot use it in writing down my expressions here. I mean, so how can we solve that? So the bottom line is, where is my pen? Yeah. Too complex, right? Complex. Yeah, I'm going to the right screen. And Talbourdet is the guy. This is the application. So Talbourdet, and what was it? Paper was from 19. Where are thou?
1941.
41. Oh, and Guy, he works at the research division of the United Shoe Machinery Corporation. I thought the University of Michigan or something like that, right? Well, why a shoe machinery corporation? Any ideas? No? Well, he was just an engineer, probably had his Master of Science from MIT or whatever. And he worked at the Shoe Machinery Corporation, and they make machinery which makes shoes. And the machinery works with mechanisms. And for that mechanism, you have to do an analysis. How much power do we have to put in? How strong must the mechanism be? And the basic mechanism in all this machine design is actually the 4-bar mechanism. By concatenating a number of 4-bar mechanisms, you can almost create any motion. So therefore, United Shoe Machine Corporation. Okay, too complex. So what is the solution? Solution to that?
Sir, can you switch to
The thing again, yeah. Air server. The solution lies in this, I guess, coffee break, right? So think about it during the break.
En dan even afsluiten.